Welcome. So excited to see more of you file in here for today's tech forum for the CTOs, the future of space and satellite hardware. I'd like to have my panelists introduce themselves. If you'd like to start.
Xavier, Bertrán, Chief Product and Innovation Officer for SES. Nice to be here. Thank you.
Hi, good morning, everyone. Mark Dickinson. I'm the CTO at Neo Space Group, and I've joined there recently. And before that, I was at Hispasat and Viasat.
Hi to everybody. Marco Brancati, just recently moved to Leonardo with the role of CTO and the New Space Division.
Hi, I'm Antonio Abad. I'm the CTO of Hispasat.
Excellent. Thank you so much for joining us. I know you guys came quite a way to come here. So we'll do opening and some context setting, get into the primary conversation, and then closing notes. Objective is to leave a little bit of time so folks can ask questions. Questions will be at the center mic at the end. So first question, the future vision. What excites you the most about what is going on in the industry right now? Would you like to start?
So if we talk about what is most exciting about the industry today, I will like to highlight two aspects where we see an important evolution in the last years. There is, on one hand, a very important evolution in what we are calling software-defined satellites, and this is allowing the possibility of reconfigure satellites in orbit. And then with this, we can reconfigure the coverage, we can reconfigure the bandwidth, and we can reconfigure the power of the satellites that we have in orbit. And this is an important element that is being completed. The development of these new software-defined satellites is being completed, and it's going to deliver a very important flexibility in the next year. The second important element is multi-orbital capacity. So we are starting to deliver not only geo capacity, that it was the one that we usually were providing for communication satellites, but we are also starting to deliver non-GSO capacity, non-GSO satellites, both in LEO and in MEO, orbits, and this is giving us additional flexibility. It's providing us better performances in terms of latency in the satellites, and it is giving us the better affordability of the capacity that we are able to provide to the users, as well as global connectivity. So the combination of these two factors, multi-orbital capacity and full flexibility, can only be combined and properly managed if we put the necessary intelligence on ground to manage those resources. So I think the most important element that we need to work today on the table is how to take advantage of multi-orbital capacities and flexibility of the satellites in orbit that we need to define on ground. And we are working currently in the definition of the systems that will allocate that with the input of I need to provide a service. These systems will be able to define what is the capacity that I will be using, what will be the frequency, what will be the orbit, what will be the satellite that we will be using for providing that service. And that intelligence of the network will be key for the efficient use of the capacities that we are developing today. And we anticipate that AI will be a key element in the development of these resources management, and will provide us the capacity not only to manage in real time the satellite capacity, but even to anticipate the evolution of that capacity and anticipating trends of traffic and based on weather predictions, what should be the best and most efficient configuration of our satellite network at each moment. And that will be key for the efficient use and for being successful as an operator, providing the right services at the right prices.
Excellent. I saw a couple head nods. Mark, you were nodding your head as well. What are your thoughts?
There's been talk about multi-orbit systems and software-defined spacecraft for quite some time, and now there's time to deliver it. So I think this is the crunch point where a lot of engineering has gone in, A lot of money's gone into it, but we haven't quite yet seen the spacecraft arriving for delivery. We haven't quite seen true multi-orbit efficiency. We've seen systems optimized for one and slightly under-optimized for another system. It would be really good to see true multi-orbit, efficient in all orbital domains systems being deployed, both on the user antenna side, but also to Antonio's point, in terms of the capacity management and how you utilize these assets in the most efficient way. Also looking forward, I think, again, there's been a lot of talk in the past about reduction in launch cost. I haven't seen that real cost come down significantly, especially for GEO. I look forward to the day that costs do come down. So seeing capabilities like Starship really come to market, whether that's in a couple of years' time, what does that do to the economics, especially in LEO or things in space? Do we care about mass any longer? Is mass almost irrelevant? It's about providing true capabilities in terms of payload performances, and if that costs another 100 kilograms, do we care if the cost is reduced? And then there's a whole bunch of in-orbit servicing. I'm a big fan of last-mile delivery type of systems. I think they allow you to optimize systems for the mission they need, rather than having to design them to be able to do a whole range of things which they're suboptimal at. So I think this in-orbit servicing will come to fruition in the next couple of years as well.
Excellent. So you mentioned a few of the elements that leads into the next question. So Javier, I'll have you start. The industry challenges. What do you think are some of the major challenges facing all of us today?
I think today we have a challenge around the cost of bit we're able to achieve with our legacy acquisition models. I think those will have to change moving forward. And, you know, we're going to have be far more agile, far more speedier in our developments. We're going to have to be using far more cost-effective solutions off the shelf. 5G NTN. If we want to really make direct-to-device happen, we're going to have to look into a different way of doing the projects and the investments and the overall developments. And I think we're currently being heavily disrupted, and we need to recognize that, you know, doing things the same again is not going to help. And so I think there's going to be a fundamental shift in the business model, and this we have to accompany with what the other Antonio and Mark have been saying. And so this is the change we have to do, and we have to make it happen.
Marco, what do you think?
Yeah. Well, I'd say for sure we have some technological challenges in front of us. Let me say that one very important is to have the real high-performance computing capability in orbit. I believe that this is for sure one of the most important elements in order to really activate the new economy that we are targeting, either if we look at the low Earth orbit, but also if we look to the space exploration, for instance. This is absolutely key, also because of space exploration, in addition to the targets and let me say to the aspiration that were described before, is something that goes with our dream. No? So we speak about the moon, we speak about Mars. We heard about the last mission, the last lander just 10 days ago, and take into account that, for instance, looking at what the European industry is doing, the moon exploration requires some enablers, which are, of course, the systems for telecommunication and navigation that allow the users over the moon surface to really be to perform the work they are developed for them. And so there is also a business challenge associated to that, which is, again, the real development of moon economy, but also for what concerns the in-orbit servicing. Now, from a technical standpoint, it is clear what is possible to be done, but from the business standpoint, probably we still need to work on some specific model for that.
Gotcha, that's great. In order to do this, materials and manufacturing have to be present. what are your thoughts on the advanced materials and shaping for these future endeavors? Mark, we'll start with you.
Yeah, so really good point about manufacturing needs to change in space in the future. We've been heavily disrupted, but the manufacturing is key. But what we can't do is lose sight of reliability. The rush to be able to design low-cost systems that can be mass-produced cutter spacecraft is a great concept. But really, you need to do that with reliability as well. No one customer is going to thank you for building the cheapest spacecraft possible if it doesn't work. So you really have to. We can't forget about the engineering behind it. We have to bring new manufacturing techniques, 3D printing, for example. We have to be able to use the latest sort of production line thoughts and supply chain to be able to really achieve the goals of this low cost per bit. I agree. We need to have that. We're in a world where cost per bit is fundamental. But the systems have to work and they have to be reliable because the vast majority of SATCOM systems are there for years and customers spend a lot of money building infrastructure to use them, and we have an obligation to make sure that we design things robustly to be there in the future.
If I may, I think we're going to also see a shift from previously there was a lot of integration of components with a lot of harnesses and a very complicated setup. I think we're going to see a move from less harnesses, more integrated circuits, more stacking, more, let's say, higher volume, higher scalable solutions coming forward. And I'm really looking forward to that because that would enable us to really shorten the lead times, being able to actually scale and do things more quickly. And so I think that, harnesses are, sorry to ride on this point, but, they're in the assembly process. These are the things which are creating problems, issues, and so on. So I see there's going to be a shift in the way we're going to design satellites and vehicles into more integrated systems.
Yeah, I would say someone has shown us that probably, the traditional approach to have all the components fully certified before being utilized in space is something that needs to be at least revised. Okay. So, of course, this is one of the most important challenges since, again, I mentioned before the high-performance computing. Okay, we need to really understand how much commercial solutions are reliable in order to be utilized, of course, in the outer space, also against, to face radiation and this kind of a harsh environment. We also need to develop inter-satellite link equipment which are going to be as much efficient as possible in the new bandwidth. And I would say quantum computing and the utilization of quantum technologies are going to support also our next steps in space. Not to forget also the improvements on propulsion. So these are elements that on which, from a technology and industrial standpoint, we need to push.
Yeah, and I think it is also very important to realize that the development of constellations is giving us an opportunity to make a different approach for the manufacturer and in general for the reliability of the systems, because constellations allows for the distributed reliability concept. So what I mean is that in a geo satellite, all the investment that we were making was in a single element, and this element was failing. There was a loss of several hundred millions that for the company, and you were not able to provide your services. However, in constellations, because there is a number of satellites that are providing the services, it is possible that some of these satellites may be failing without impacting the provision of the services in general. So that is opening a door, is giving an opportunity to considering manufacturing with lower reliabilities that we've been using in the past. So in geo satellites, there is a very strong quality and product assurance requirements that is impacting the cost, but it is required in order to achieve the reliability of being able to work, to function in orbit during 15 years without the intervention of anybody. However, in constellations, there is the possibility to build with lower reliabilities, and that's opening the door to the possibility of manufacturing processes that don't require to have to provide such big reliabilities like we are used to in the past. And there is a very interesting opportunity there that can be taken in order to reduce the cost of the capacity. That is one of the challenges that we have ahead in the next years.
It's a great segue into the next question of scalability and infrastructure. What are some of your strategies that you're bringing forth for your development in order to obtain scalability and to bolster your infrastructure? Start with Mario.
Yeah, I would say let's give me the chance to speak a little bit on a portion of space systems which sometimes is not always considered for the importance that it has. That is the ground segment. So we saw a huge change of paradigm in the last years for what concerns the development of ground control systems. We moved from an approach where each satellite had its own piece of ground. So from an approach where we were focused on one single sensor on board the satellite, to an approach that targets a multi-sensor, then a multi-mission, a multi-constellation, and a multi-domain approach. So in moving from this original approach to the final target, which is the multi-domain approach, the ground segment has to be redesigned completely with a really, let me say, a scalable approach. That has a direct impact on the new generation infrastructure. And so this is something that on ground, companies involved in that, of course, are facing. This also allows, to have a space segment considered not as something that is standalone, but is completely integrated with, especially looking at space to be utilized also for defense. Okay, being fully integrated with what is the land, the air, the naval segments, which are the traditional ones, included, of course, the cyber security trend. And so this is for what concerns the ground. Looking at space, and of course, since you are also asking us about sustainability, it is clear that we really need to understand whether the possibility to build in space utilizing materials or subsystems that have already been used on missions which go out of order is something that is possible. If that is true, and we think it is possible, this is something that in terms of scalability can give an important support, because we can be more efficient in that respect. Also having in mind that, as we know, space is large, but recently, there is a little crowding of that.
Two things. One, I think we're going to see more verticalized players coming forward, which will then take and have better control over their own scalability. And we're already seeing that in the new space area, where most of the new entrants at the moment are really verticalized. So taking control of their infrastructure in a much more greater depth. And then the second thing is really from our perspective is the adoption on the ground of telecommunication standards in order to drive the ground segment, making the ground segment far more capable of adapting to any space segment or network we have, and actually thinking of the space segment as a network, no longer as a series of satellites, but really seeing it as part of the overall fabric of the network, whether with optical data links or an RF, and really seeing it as one. and really using then the ground to basically interconnect and make it a scalable system in a sense, which is, by the way, not what we have today. Today we have separate systems as they have been procured in the past with different networks set out. So that's, for me, then the way forward then from where we are today.
Yeah, I think probably we've all had spacecraft which have been heavily delayed by one supplier for one part. It's the nature of how the business has been in the past. We have to move away from that to the modular type of approach, interchangeable, more vertical integration, to more the spacecraft manufacturer has more control over delivery. I think that will help a lot in terms of giving back some credibility to delivery times. Because at the moment it's a bit of a joke. People say, yeah, we get a spacecraft in 2 years, and you really know it's actually another date. Coming back to Antonio's point, which I think is excellent, about how you build a system. Maybe you can reduce reliability for a payload element because you have a multi-orbit, a constellation with multiple overlapping coverages, and you can accept a lower reliability. But there's other parts you shouldn't accept low reliability on. If your spacecraft mission critical, it needs to be controlled, and it's above 700 kilometers, a spacecraft that has a 10% chance of failing is going to be, we're going to end up with a lot of debris. And space sustainability is a hot topic now, but it's going to become a more hot topic as more and more mass is launched into space, especially if we start accepting lower reliability rates for end-of-life activities. So we need to choose where we pick our reliability. A platform reliability may be one number, a payload reliability may be another number, and we need to think more holistically about this, because space sustainability is going to be if you look at the number of spacecraft up there now, and we're looking to see Kuiper, 1,000 Sails, Telesat, there's Iris Squared, there's going to be a huge amount more mass put into orbit, and we need to make sure we manage that responsibly.
Yeah, and I would like to reiterate a little bit what Xavier has explained about the integration with the terrestrial infrastructure, because I think that is key for the scalability of the system. I mean, we can only gain scalability if we integrate with the terrestrial infrastructure. And I would like to highlight in this sense the proposed architecture that we have for Iris Square program, where we are defining the satellites exactly as Xavier has said. The satellites becomes nodes of the network. They are GNOD bits, they are 5G nodes that are operated in parallel with the terrestrial nodes. So at the end, the telco operator will manage terrestrial and space nodes in a seamless manner. And I wanted to introduce another element that was the definition of new services that will also help in the scalability of the system in the future. And in that sense, I would like to take a couple of minutes to explain about quantum key distribution, because this is a new application for satellites that will be very important in the next year. This is a response, a reaction to the reinvention of the cryptography that will need to come in the next years as a consequence of the threat of quantum computers to the classical cryptography. And it is very important to highlight that the use of quantum key distribution, which is one of the alternatives to solve this problem, requires from the satellite infrastructure, because the transmission of photons, that is the way we are using this QKD through fiber, has a limited range. So it doesn't get further than 100 kilometers. So it means that we'll be able to transmit keys via fiber in urban areas, but if we want to go to interurban or international connections, we'll need to use satellites. And that is very important for the future use and scalability of the system. In our case, in Hispasat, we are developing the first geostationary QKD system in the world that will be able to provide GeoQKD to 1/3 of the world at the same time from a geostationary satellite. We have already funded more than 100 million euros for the development of this new system that is under development today. We are expecting to finalize the development for 2027 and to integrate in a future Hispasat satellite that will be flying by end of 2028. So we are expecting by 2029 to be able to provide QKD services to 1/3 of the world from a single satellite in a geostationary satellite capacity. And this is only, and I'll finish with this, and this is only the beginning of something that will come, that is quantum communication. There is a future about, and we have a patent on that, about the capacity of satellites to connect computers remotely located that will be the basis for what we are anticipating that will become the quantum internet.
That's fantastic. And 2029 isn't that far off at this point at the rate that, it seems like all the change and, quantum computing, AI, ML. How do you see that whole tool set coming into play with your future work? Antonio, would you like to start?
Oh, yeah. So I've been talking about quantum computing. Let me say a couple of words about artificial intelligence. People used to say, and I've been hearing that, I'm coming from the NWC in Barcelona, and the main topic in NWC was AI. Everybody was talking about AI. Everybody is doing AI. So I would like to take it a bit down to the earth, because everybody is saying that they to be doing artificial intelligence, and I think that there are several areas where I really see the application of artificial intelligence in our world. The first one is in telemetry analysis. We receive massive flows of telemetry from our satellites that need to be reviewed by engineers, where the artificial intelligence in the management of big data, the analysis, the trend analysis, the prediction, the diagnosis, the prediction of anomalies, all these topics will bring a lot of benefits. Second one, I spoke at the beginning, resources management. We have a lot of flexible, different, diverse resources today, and it will be very difficult to manage all those resources only with a human being. So artificial intelligence for resource management will be a key. And there is a third one that is not that common, and I want to announce here, and is that we've been lately discussing with some people that using, and allow me the technicality, quantum-inspired software technologies, don't ask me the detail of what is that, but they have demonstrated in an iPhone to introduce in 200 megabytes, in 200 megabytes, to introduce an artificial intelligence model of a natural language model. So if we have the capability of putting an artificial intelligence machine in a 200 megabytes, that gives us the possibility to introduce artificial intelligence on board of the satellites. That is something that we never considered in the past. So we are looking at the possibility to, using artificial intelligence on board of the satellite, define autonomous control of the satellite, and the possibility of managing events of close proximity at satellite level with autonomous system using artificial intelligence.
Yeah, and AI is obviously going to be fundamental, and I think to the spacecraft side is one. The downstream side is probably where the money is in terms of commercialization of data. And at Near Space Group, we're looking at SATCOMs, Earth observation, IoT, and PNT. And how do you provide end-to-end integrated solutions to customers? So the classic example is like agriculture. You can have Earth observation to look at crop yield. You can have an IoT sensor to look at moisture in the soil. You can have a PNT system so your automated autonomous combine harvester can stay on track and doesn't fall into a rut. And then you have a communication system to get all the telemetry back. Now, a customer doesn't want to worry about 3 different systems, 4 different systems, and how they're integrated together. Now, can AI actually provide that managed service, abstract away the sources of the data, and just provide a much cleaner sort of interface for the customer to use? They just want to be able to get the maximum yield from their production using the tools they have. And AI has a great power to be able to do that orchestration in the background and provide a much simpler interface. Just as you use ChatGPT to ask a complex question, you can abstract all that complexity using AI away from the user. And I think that's really where the power in SATCOMs, and that's where I think, to be honest, where the revenue will be in the future. That's where AI will really empower SATCOMs to do far more than it has, and SATCOMs, Earth observation, all the sectors from satellite, in a far more powerful way than it has done in the past.
That's excellent points. Marco.
Yes. Difficult to add additional areas where to utilize artificial intelligence. Let me say, I fully agree with Antonio, and in general, I mean, everybody now speaks about artificial intelligence applied everywhere. Okay. We need always to remember that we need artificial intelligence once we have a huge amount of data to be processed, to be categorized and utilized. Otherwise, we are talking about very sophisticated software. But so this has to be clear. So, for instance, going back to the utilization of artificial intelligence on board satellites, for sure this is very important for what concerns the Earth observation and, in general, the geoinformation utilization of space. Just to make a very clear, simple example, no? If we have satellites with optical payloads that, of course, observe the Earth, we know that there are some physical situations where observation is useless. No? And why to send on ground all this amount of data without processing them on board first? It is true that we said that one of the key enablers is a new generation of intersatellite links, optical links. But of course, if you can optimize, we also know that optical downlink is not really the solution for every situation. No? So we need to consider that. An additional area goes to operations. So. Antonio mentioned the processing of telemetry. Okay, there is also the maintenance of the ground infrastructure, and so all the data that you collect can be processed quickly to understand where you have to act, but also in operations in the space. So, for instance, going back to in-orbit servicing, when we have the docking phase, when we have the proximity phase, this is something that, especially if your tag is equipped with sensors that collect also from a visual standpoint data, because the issue in that situation is that we have a lack of data, differently from other areas. Of course, here we speak more properly not about artificial intelligence, but machine learning and the way you teach your system to autonomously behave in performing what is needed. So this can be considered as an additional utilization with respect to what already
Javier.
Look, I think my hope would also be that AI helps us develop quicker. There's no doubt that we're moving to become much more a digital company. Software is everyday life. And so in that context, from my perspective, to add to what has been said, is that AI will become something we'll be using for developing the systems, analyzing data and so on the ground. And I think that's the biggest area of application.
That's excellent. Moving on to the next part of our questions, Moon, Mars, or beyond. If you had to be on the most commercially viable option, what would you be picking right now? Mark?
Oh, tough question. I would say Mars. I think the economic benefits or the resources available on Mars far outstrip the Moon. So I think there's far more potential to be able to develop capabilities on the Martian surface itself, rather than have to ship everything backwards and forwards. So yeah, I think the Moon should be a stepping stone in some ways, but I think Mars has far more potential to be able to have natural resources and exploit those natural resources to develop capabilities and resources in situ, rather than having to spend a lot of energy getting it backwards and forwards from the Earth.
I think that at the end we'll go to the Moon to go to Mars, and we are still in the first step. And in order to go to the Moon, our interest is to develop our capacity to provide communication services to those missions to the Moon. we are working with Telespazio and with Viasat in the development of a program that will develop a specific infrastructure to provide communication and navigation services in the moon. And what is most important for us, to create the first lunar communication operator service provider in the world. And this is our interest, and this is what we are expecting to create in the next years. And we are strongly expecting that this will not only be the first lunar communications, but it will be transferred to Mars or whatever external exploration services are required. We will be able to provide communication infrastructure, navigation infrastructure services to those companies. So I think this is our view. Yeah.
Excellent. Javier.
I think Mars, because at the end, if you open up Mars, you're actually opening up space travel, right? Beyond the Earth confinement, I would say, in my language. So, from not just from a business case perspective, but from a, for humanity, that would be a big step.
Well, I'd say for sure Mars is the target. I would say a little medium long-term target. For sure, we know Mars has an atmosphere, so some phenomena that we need to face on the moon are going to be mitigated on Mars. But Mars, of course, is not too close. So going back to the moon, I believe that the moon really represents the opportunity from here in the next 15, 20 years to understand exactly what are the issues that we need to face in order to go to Mars. And by the way, again, what was done by, for instance, the European Space Agency in asking for service operators, to be the leaders of the development of a system which provides telecommunication and navigation services on the moon's surface, is a clear indication that we are not going, again, to go back on the moon because there is some scientific purpose or some scientific goal, but we really want to understand whether all of that can activate an economy. So we know which are the reasons for being on the moon. We know about the rare earth. We know about helium-3. But in addition to that, we need also to understand that once we stay there and we have limited resources, how to learn to solve the issues, and then we will be ready to go to Mars. Again, Telespazio was mentioned. Leonardo, in general, are very, very committed on that. And we really believe that also working in a joint approach with NASA, you know that the Moonlight program is associated to a program from NASA, is something that can expedite the process.
That's excellent. What's one bold prediction, if you could make, for the future of space and satellite hardware? What's your bold prediction? What's coming up next?
Can I make something provocative? And for the first time in the chat, I'm not going to talk about my business. Bold prediction, food for thought from Crazy Antonio. It's about rockets. So we all believe that rockets has progressed and had advanced a lot in the last years. But if you allow me, the way I see the rocket technology, specifically propulsion, is the following. Rocket equation, this is from Tsiolkovsky's, the beginning of the 20th century. The design of a rocket engine is, believe me, and I'm trying to provoke a little bit, it was defined with the German V2s in the Second World War. And there is not much of a change from that design to the current rocket engines that we are designing today. So I'm really expecting for 2035 that there will be a disruptive change in the propulsion technology that would allow us to go to the space in a more efficient way, and that will provoke two things. It will provoke a significantly lower cost to access to space, and second, better access to the outer space for the humankind. I'll leave it there. Food for thought.
Look, I'm going to be a bit provocative with Antonio. My Eagle 1 project with QKD on LEO will be launched earlier than his. And hopefully we'll have the testbed up and running, and people will be able to test out things and try and move ahead on that technology. And yeah, but again, we didn't mention it really, but I think direct to device is the other area which, if we can eliminate the user terminal and everybody can connect with its own smartphone, that would be a big, big step. And I think that's also another thing which is coming for sure.
Yeah, and direct-to-device has the potential. I think the business case, for me, the business case is still challenging. So let's put out the technology, yes, is a great idea. I think what I'd like to see is some space-based solar power in the future. Having moved to the Kingdom of Saudi Arabia, that's a country that's based, its economy has been founded on an energy business, but it's a perfect place to be able to start doing experimentation on space-based solar power. That's going to be an unlimited resource that's available for the vast majority of the time. Doesn't worry about night or anything like that if you have your spacecraft far enough away. I think that has the potential to be really disruptive for the energy sector globally.
I fully agree that propulsion on one side and utilization of solar power in orbit, are going to be probably, targets that we could hope to achieve in 10 years from now. At least, to get closer to such targets. But in 10 years, let's say, it's not a long period of time. In this time frame, we know that the commercial stations will take over, the ISS. So what I would like to see really, the presence of normal persons in the space. Normal, of course, still thinking about technical guys or scientists. But if we really say that we want to go towards the outer space, we need to learn how to be in orbit, but in a different way. Also for performing more normal activities. So to start considering the activity performed on Earth, something that can be partially moved in the space. And this will really mean that we are getting ready for moving from Earth, although we know that there is no a B planet. And again, for instance, we spoke about before high-performance computing in orbit. Let's think about really utilize space nodes for storage. This is something that, in my opinion, can really help also for security reasons, and is something that, together with having technicians in orbit, can be an achievable target in 10 years from now. It was a surprise some months ago when we had at the same time 17 persons in the space from different missions. 17 persons is one row of our colleagues over here, our friends over here. So I'd like to see something more in that.
That's excellent. I have one last question for you all before we go to audience questions. What is your call to action from the industry for all of us to be successful, to hit these goals, to hit the moonshots, to hit Mars? What is your call to action and what you need to see from the industry, from where you sit as CTOs? What are you needing to see from the community? And what is your call to action so that we can get to Mars and beyond?
If I may, we need a real cooperation. We need to work together. We know that these are, space is exciting, but if we really want to have the possibility to utilize the space for a benefit on humankind, we really need to cooperate. So this is, in my opinion, as mandatory.
Excellent. Mark?
And if you look in Southern California, you see so many startups that have spun out of SpaceX. So many people have been through the SpaceX training camp, have come out and have access to venture capital, have been able to build a business. Now, probably 90% of them may not be super successful, but 10 of them will be really big companies in the future. And I think looking back globally and coming from the UK and seeing Europe as well, I think we need to be able to get better access to capital and foster a culture where that type of risk-taking is promoted. Because I worry that if it's just large organizations trying to get government funding to do things, it will work in the end, but it's going to take a long time. So how can we take some of the model that's worked, I think, quite well in one part of the US and be able to sort of bring that globally as a good model for innovation and investment?
So, Javier?
Look, I would join Marco on this one, where I think peaceful collaboration for, in space is actually the most important thing. What we want to avoid is, past history where new areas have been explored and other things happened. So I think peaceful collaboration on Earth, on the Moon, in Mars, and clear ways of, going about with space in a sustainable manner as well, and taking care of it would be my choice.
Antonio?
Leveraging on Marco's idea of cooperation. I think we need to change the way we are working with the industry. And we need to cooperate in a more fluent and we are calling it a co-engineering. I don't know exactly. We need to find a more flexible way to work with the industry. I can recall an example of our past experience where during the pandemic, we were building a satellite. And because of the pandemic situation, and you can imagine, there were significant changes in the market, and we decided that we had to change the design of our satellite during the course of the design and manufacturing of the satellite. It was still at the design. I think we'd done the PDR or something like that. And we decided to change the design of the satellite. And at the end, the result is that we had to remove one antenna of the satellite. I tell you, it took us 3 months to agree with the manufacturer, that is a very good manufacturer with whom we have a very nice and fluent relationship. So I'm not complaining at all. This is the best that we can do with the current standards. That is that you have a contract, you have a V flow for the development, blah, 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 blah. With this scheme, in the best of the scenario, it took us 3 months to remove an antenna from one satellite. Guys, we are not going to move in that direction with this approach. It's not going to work. We need to do things in a more efficient way. I don't know what is the way to make it, but I know it cannot take us 3 months to remove an antenna from a satellite. I'll put it there.
So we have collaboration, capital, and speed for the call to action from our CTOs. We have a few minutes available for questions from the audience. I ask that you use the mic in the middle so that we can all hear.
I think you mentioned directed device as the next big thing, and then you mentioned the business case is not there for it. Would love to hear from a hardware perspective, what does it take to make the business case for the directed device? Like across the board here, like there are two camps, one saying that directed device is the way, and one camp that said that it's not cost effective.
I can have a go.
Go.
So, look, the potential of opening up a space ecosystem that's been very niche and small to a mass market, to consumer devices, is extremely exciting. There are a number of challenges, and they can all be overcome. So these are things that have to be addressed. There's a sort of a technical challenge. The base station is 100 times further away, moving fast, maybe 1,000 times further away than the terrestrial base station. So the link is impaired. So you need a lot of technology on the space side to be able to recover the link performance if you want a like-for-like service. There's the issue around spectrum, and we're seeing lots of discussions at the moment around the use of terrestrial spectrum and mobile satellite spectrum, and I think we're seeing a move towards the MSS spectrum has a real advantage over terrestrial spectrum, whether it's ability to scale coverage or the opportunity costs for the MNOs. But I think fundamentally is what is the experience the customer is going to get and what they're willing to pay for. Now, T-Mobile, I think, are charging $15 per month for texting. Is that really, is there enough people willing to pay that much per month to maybe use a couple of texts if they're out of coverage? So I'm going to hop to the Kingdom of Saudi Arabia. 99% of the population have access to 3G or 2G connectivities, same text service you can have today. That leaves a couple of 100,000 people only as an addressable market. How many of those people will you get? Will they pay $15, $20 more per month to have that access? So I think there's a huge potential for direct-to-device. And it may not just be the smartphone. It may be IoT, it may be automotive. There's different sectors as well. But yeah, I think we really have, the consultant's right, there's a $30 billion opportunity per year for this. I would like to test that a bit. Is it really $30 billion? Are consumers really willing to pay that more? Or is it more an M&O play to be able to retain customers or to upsell to customers? So I'll leave it at that.
Look, I think Mark has touched a bit on it. We always think about direct-to-device for the consumer. I think it's a complement. That's my first point. It's a complement to what is already existing on a terrestrial level. And what we are seeing is that there are a couple of sectors which are really interested in using the technology. That doesn't mean that the consumer is the end customer. And there's ways to construct a system which allows you to do it in a very focused manner. And so if you combine those two, and in any case, there is already today some markets which are using satellite communications for leisure, for other maritime purposes, leisure purposes, and so on. So you're effectively replacing those markets as well. And so when you look at it, yeah, I mean, there is a space, but will there be many players? No, I don't think so. And again, it will be complementary to what you have on the terrestrials.
Excellent. Another question?
Hey, I'm Abdullah, and I have a question for you, Dr. Mark Dickinson. How do you think New Space Group leveraging AI to enhance satellite autonomy? What key challenges are you expect either now or in the near future?
Well, the key challenge is to when you're designing new space infrastructure, you have to build it. You have to build in the capability from the beginning. So there's a bit of a ramp-up time to take. I think from what I've seen so far, I think the real power of AI is, again, I see it more it's going to help satellite operations, but that's over here. I think the far bigger opportunity is looking at how AI can radically change the downstream service, what the customers experience and how they use it. The Earth observation, we have an Earth observation business well established, which is integrating data from multiple sensors, whether it's electro-optical, SAR, but you want to produce products at the end. And what the customer has a question that they want to know the answer to. How can we use AI to be able to provide the answer quickly? I go back to my ChatGPT example. It may be using some SAR data. It may be using some infrared imaging type of sense. That's what AI is super powerful. It's back to you have a huge amount of data. A human can't aggregate it together to answer the question. And that's where it comes from.
Yes. Let me say something good for the new space, and let me give you some good words for that. New space has the difficulty that they don't have the heritage of having done the things before. And I think that there is an opportunity for this situation in the case I described before about the constellations. We see some difficulty in the consolidated companies that they have a strong heritage, that they have a strong quality system, a strong standard process, where they're following all those standards for many years, building geo satellites with the adequate quality. If now we need to build constellations with satellites with higher failure rates with lower reliability. It is very difficult for companies that have been doing things with a standard of quality like this to say, now, forget about everything that we've done in the last 50 years, guys, and we're going to build like a shitty things that in this level of quality. It's not that easy to change the culture, change the procedures, to change the processes of companies, and to change the quality level. And there is an opportunity for new space companies because they don't have the heritage. And in this case, heritage is not exactly a good thing. And this gives them the opportunity to start building things with the new idea from a fresh approach that I think it's a real opportunity for new space. So I will encourage new space to test all these new ways of manufacturing things with different levels, different approaches that don't necessarily need to match the original targets of reliability of the space business, but that may be sufficient for this distributed reliability concept. And I think there is a good opportunity.
Excellent. And we are at time. Thank you so much for joining us. Thank you so much.
Thank you, Sheri.